This is vectors ijk is the name of the lesson. Yeah. Okay, so I told you this last time. Vectors ijk, they're called basis vectors, and they're always like this. I is always a vector in the horizontal, 1 unit long, and j is always a vector in the vertical, perpendicular, and also 1 unit long. So these are called the ij bases. And in fact, you can do these in 3 dimensions as well. So you could do them like this in 3 dimensions. I, j, and k, like that. But that is not something we'll worry about today. We're just going to, for the most part, look at 2 dimensions. Okay, so let me zoom out. So in fact, with this, you know that any vector can be written as the sum of 2 factors. So for example, let's say this vector here. What would you say that is in terms of I and j? 2i, no, be careful. Yeah, 1i plus 2j is 1 east and 2 north. Okay, and then let's write another one in here. So let's say, oh, that's a little bit off. This vector here, what do you think that one is? 1i minus j. But what's really nice is that when you write the vectors in this form, they're very easy to add together. So for example, this first vector, 1i plus 2j, if I add it to this vector, the i's and the j's add together like in algebra. So how many i's do I have? 2 i's, and how many j's? 1j, like that. Okay? So that vector there would be 2i and 1j. So in fact, if you add them together, you'll get this vector. Yes, oh, that's a little bit off. Roughly something like that. So using I and j provides a convenient way to add vectors and also to multiply them as well. So as another example, so here is my I and then here is my j. So let's say here is 2i plus 2j. I'll call that vector A. So what would 2a equal? 4i plus 4j. So that means if that's A, then 2a would be like this vector here, which of course you know already as well. So my point with this part of the notes is that I and j obey the normal algebra rules and they provide a convenient way to draw vectors. Let's have a look here. Yeah. Okay, do you have this taken down? Not yet? Okay, go ahead. Let's go. Do you write all this, Curdy? For sure? For real? All right. Right. Oh. There is no up here. This is everything.
No.
Yes.
Oh, sorry. Why is it 2J?
Where?
The one
Here?
Yeah.
This one here? Sorry, that is for the top one here. And then this is for the bottom. Sorry, to make that a bit clearer.
No, why?
This one, I give you this one, and I give you this one, and we add them together to make this one here.
That's given?
No, that's the one we find. This one here is like the A, this one here is like the B, and this one here is what I want, the A plus B.
No, the A and the B are given.
Yes. Yeah.
Is that 2I plus 2j? Or it's
Yeah, 2I plus 2j. Multiplied by 2 then. Albaharna, here, Fumi, yes, Fiend, yes. Precious, Sarah, Hin, Marana. Brendan, no. Joseph, no. Abanoob, no. At home doing their physics lab report? At home doing their physics lab report? Oh well. Hassan, yes. Sadiq, nearly. Sayoun, yes. Kurdi, yes. Faisal, yes. Okay. Now, let's have a look here at the questions. No. Okay, so we want to draw these. So just as a practice for your I and J, okay? We'll do these together. I'll give you a moment to do them. So can you draw for me A and B? Put them on the same graph, A and B here. You need me to zoom in? Draw A and B, please, for me. So the A, let me show you. So what I want,
both in the same graph?
yeah. So here is the I, here is the origin, and here is the J. Okay. So minus 8I plus 6J.
Minus 3I minus 6j.
Wait, what?
Minus 3I minus 6j.
What are you doing? What have you done? Have you added them together?
Yes.
But I didn't say that.
You said that.
Did anybody hear me say the word add? What did I say? What verb did I use?
Draw.
Draw.
Okay.
Draw both of them. But don't add them. Oh, Curdy. Alright. So, sorry, I lost it. What was the first one? Minus 8I, so that'd be about 1, 2, 3, 4, 5, yeah, about here, and then... Okay, so it's going to be just roughly some large factor in this direction. And then what was the other one? 5I minus 12j. So that would be 5I minus... So that would be... whatever. Something like that. They won't ask you to draw it in the exam. All I'm wanting you to do in the first one is just to remember the I is horizontal and the J is vertical. That's all. Alright.
The second one is 5j, 5I and 12j.
Minus 12J, I thought.
Minus, no, it's... Oh, yes,
Okay. The idea with the second one is just for you to appreciate that they follow the normal algebra rule. So if I look at the first one, 4 times 2I minus 5 times 9j. What would that be? 8I minus 45j. Oh, derp. Yeah, that should be a j. Okay. So what did we say? It was 4 times 2I minus 5 times 9j, and that would be 8I minus 45j. Alright, let's look at a more difficult one. So next now, I'll switch back, don't worry. Let's do the second one. 9 times 4 plus 5 and 9 minus 7 and minus 7. So 9, 4, 5, 9, 7, 7. So 9, 4, no, 5 plus 9 minus 7i minus 7j. So if you want to picture this, you have the vector 4, 5, and then you multiply it by 9. Then you have the vector minus 7, 7, and then you multiply it by 9. And then you add the two vectors together. So the first one will be 36i plus 45j minus 63i minus 63j. So in total 40, 50, 60, 24 minus 27i, and then 50, 18, minus 18j. So when you multiply and add these vectors together, the result will be a vector that's quite large and negative in the I and the j.
Is the lesson all like this?
Hmm?
Is the lesson all like this?
It'll get slightly more difficult, but really it's mostly this. Yeah, now that we're moving away from the thinking
Yes.
and back into the algebra, things start to feel better now, don't they? Yes. Okay, so I'll just give you one to try. So we'll just try 2c and then we'll move on to the next one. So 2c. So I'll let everybody, by the way, before somebody asks me for a third time, this should be an ij, ij. Yeah? Okay, so what did... no, we'll wait another moment. Okay, so what do we get here? Yeah. How many i's? Minus 14i. And how many j's? Minus 16 j's. What's wrong, Curdy?
Minus 14.
That's what we said, yeah? Minus 14i. And minus 16j, yeah? Yeah? What? No, don't tell me I have to multiply and add for you now. Is it minus 14i? Oh no, don't do this to me. Just take out a calculator, everybody now, okay?
9 minus 16.
For sure?
No, minus 49.
Which one did you do, C or D?
C.
C, yeah. So why are you asking me C or D, Curdy? Curdy, who's your listening teacher? For real, who's your listening teacher? But you seem like you're not sure who it is. You're like, oh. Do you skip his classes? Alright. I'm not going to multiply and add for you. We all have more respect for ourselves than that. What I will do, I'm going to do all of this one here, okay? So I'll just redraw this here. So I've got, oh, I didn't put the lengths in either. Let's just go with 3, 2, 2 for the lengths. Okay. So it's 30, 60, 30. And with the horizontal, with the vertical, and with the vertical. Okay. 3, 2, 2. All right. So I'll just draw that again here. So this one here was a 30. And then this one here was a 60. Wasn't that it? And then this one here, oh, which way was it? To the left, wasn't it? To the right. And this one here was a 30, was it? It's not to scale. They shouldn't be straight like that. 30. And then, what did I say I'll do? I'll do a 3, 2, 3. 3, 2, 2. Okay. So first piece of business to take care of is you have to write these three vectors in terms of I and j. So what we do is we just look at them all as triangles. So that's the first triangle here. So if we break it up as a triangle like this, we all remember sine and cosine. So I'll skip the calculations and just tell you straight away that this side here would be 3 cos 30 and this side here would be 3 sine 30. Anybody who forgot this, I remember doing an entire lesson where I had like 12 triangles on the page and I asked you for the horizontal and vertical. This side here, this one here would be a 2 cos 60 and then this one here would be a 2 sine 60. And then here, this would be a 2, who knows? Very good, 2 cos 30, and then this one here, 2 sine 30. So now, flicking to the side here, I'll write down each one. So this is an A, a B, and a C. So A equals, what's 3 cos 30? Can you type that in? Is cos 30 a half or root 3 over 2? It's root 3 over 2. No, it's a half.
0.4627.
Are you in radian mode?
Yes.
It's root 3 over 2? 3 root 3 over 2. Cos 30. Oh, for goodness sake. Curdy, just type in cos 30 and tell me what you get. Wait. Are you in degree mode?
Yes.
Okay, go ahead. Root 3 over 2. Good. So this would be 3 times root 3 over 2i, and then sine 30 is a half, so plus 3 over 2j. Then for b, it'd be minus 2 sine 60, so that's minus 2 root 3 over 2, so they cancel I. And then the vertical is 2 cos 60, which is a half. So it's 2 times a half, so that's just a 1. And then the last one down here is C, which will be 2 sine 30. Sine 30 is a half, so that's 2 over 2, so that's 1. Then minus, because it's going down, 2 cos 30, which is 2 root 3 over 2, so they cancel j. So if I slide over here, so A is 3 root 3 over 2i plus 3 over 2j. B is root 3i plus j. And then C is I minus root 3j. So make note of that. Okay. Right, so that's actually part 1, part 2, and part 3 done, where I ask you for the A, the B, and the C. So I'll give you just a moment. You tell me, we'll go back to the graph. Tell me what the vector AB is. So AB is the vector from A straight across to here, B. So you tell me what AB is. Do you have it? No? Any? What do you need to do first? You don't need the diagram first to find AB. No, guys, think for a moment. AB. B minus A. So that would be root 3 minus 3 root 3 over 2I, and then 1 minus 3 over 2, so that's minus a half J. Yeah. Okay. All right. Now give me AC. Give me AC now. You don't need the diagram anymore. So give me AC. Good, okay, so you can write it down directly. AC equals C minus A, which would be 1 minus that fraction. Where's my cursor gone there? 1 minus 3 root 3 over 2. I. And then, hang on, C minus root 3 minus 3 over 2. So plus minus root 3 minus 3 over 2J. Okay, and then the last one here for you to do is BC. So let me just write this down. So BC, B was a root 3 and a 1. So it's C minus B, so 1 minus root 3I plus minus root 3 minus 1J. Okay, so for BC, do you have it there? It should be 1 minus root 3, 3I plus minus root 3 minus 1J. Here?
Yeah.
C minus B.
Because it's minus 3I.
Is it? There's B there.
You didn't take the minus.
Oh, I didn't take the minus, thank you. Wait, guys. I didn't have the minus here on my B, so let me just add it in. So there should be a B here, a minus here. So that changes this one here to a minus. And then here, minus and minus, so plus then. Okay, so please make those changes. Okay. Right.
What if we get the answer for the first one, the B minus C?
What do you mean?
Like the answer.
AB is B minus A, and I give you B, and I give you A.
No, but then it's a plus minus 12 with B. We don't have to get the answer.
Why didn't I, or why did I?
No.
I'm not sure what you're asking me. Okay. Now, I'll just give you a moment to think about this one. I think you can all try it. I want you to find another vector called D. And I want you to make this vector D in such a way that when you add it to the other three vectors ABC, the total will be 0. So I want you to find a fourth vector D. When added to ABC, it cancels it. So what do you think the first thing is you have to do? Any ideas? Yeah, add ABC first. So that's your first piece of business to take care of. So I'll go back to the ABC here. Right, so there's A, B, and C there. So I want you to find a fourth factor called D, such that when added to A, B, and C, it'll total 0.
So I will add this.
Yeah, well see, there's actually, oh no, I don't want to tell you too much. No, try it for a minute, okay? Because there's two ways to think about it. Okay. Huh? I want you to find D so that... Huh? Yeah, I want you to find D, so make it D, so that when you add it to ABC, the total is 0. So I want you to tell me what this must be. Give me your calculator, Curdy. Okay. Does anyone think they have an answer? No? Alright. So, like I said, there's two ways to do it. The first way you could do it is by finding ABC and then looking at what that is and change the sign. You know, so for example, if A plus B plus C was 2I plus 3J, then what would D need to be? And we need to be minus 2I and minus 3J. But the other way to think about it, which I think is easier, is you just say D will equal minus A minus B minus C, which will equal minus A plus B plus C, which I know is the exact same thing really. Anyways, when you add A, B and C together, you should get 2 plus root 3 over 2I plus 5 minus 2 root 3 over 2J. So then the answer will just be the minus of those. So minus 2 plus root 3 over 2I plus 2 root 3 minus 5 over 2, that's a 3 there, J. So that'd be the answer. Where, no, I put the minus inside and flipped my numbers around. What? No, please don't say how. What? What do you mean how to do that? No. No. Oh, are you allowed? Oh, of course you are. You can do whatever you want once it makes sense. So minus of x minus y is y minus x. You know this. Minus of x minus y is equal to y minus x. Now, do you need to write that down? Yep, okay. Okay. No? Yes? Okay. So let's see, back to the question now. So that was part 4. Now, part 5. So it's just a bit of notation here. So it's actually quite inconvenient every time you want to write a vector to write something like 4i plus 6j plus 5k, and really you're supposed to put little arrows above it. It's very inconvenient. So the notation we use looks a lot like matrices. It's fine and normal to write it like this, 465. So when you write 465 here, what you mean is 4i, 6j, 5k. So just make note of that example of notation. And actually, this is very convenient because it is a lot like matrices. So for example, if I was to multiply this vector by a number, it's the exact same thing as what you did in semester 1 when you multiplied a number by a matrix. Part of what, yeah? Yes, and that we'll do later, but not for today. Okay. So, like as a small example, you could say something like this. 2 times 134 plus 3 times 122, that would equal 268 plus 366, and that would equal 5, 12, 14. As a small example. Yeah? Now, what I'd like to do with this one now that we got it is I want to draw the answer. It's quite difficult to draw in 3 dimensions. It's just continuing from this one here. This is an example here. I want you to simplify this. No, sorry, I did the IJK the wrong way around. Oh, what is it? This one's the I, this one's the J, and this one's the K. Yeah. In 3 dimensions. Although you can have different ways of drawing it, of course. I think for me, I usually do it this way. It's quite, actually, you might think, why don't I do it like this? I this way, and J this way. And then K you just add here. That's not the system people usually use. We don't do it like this normally when we draw it.
Isn't J supposed to be
Not in 3 dimensions, actually, which I know is unfortunate. The I is horizontal, the J is going towards you, and the K will be the vertical one then. Because K, I mean, if you think about it like this, we also use the letters X, Y, and Z. And the reason is, normally when we're talking about 3 dimensions, we always picture in our head the ground as being like the XY, the IJ plane, and the Z, the K, is this extra dimension perpendicular to it. So that's why the K is going up and the I and J is going down. X, Y, E, yeah. Okay. Now I don't need you to draw this accurately. In fact, even in the question, I don't ask you to draw it. I just want you to describe which direction it's going. So if these are all positive, then it would kind of be sitting here, going to the right. So what I want you to do in the question is to describe which way it's going. So it's going to the right because of the positive I. Also, because the J is positive, it's actually coming out of the screen. So we say it's coming out of the page. And then with the K, we just say it's going up as well. This is more important for the physics students because they sometimes ask you to describe the vector you get at the end. So you would have to say it's going to the right, it's going up, and it's coming out of the page. What would I have to change if I wanted to make this go into the page? J should be minus, yeah? And if I want to make it going down, the K would be negative, and if I wanted to go to the left, the I would be negative. Okay. Let me just have a check here. Yeah, I'll go back to this. So as you can see, for this lesson, I did not need to refer to any kind of diagram for the most part for the questions, okay? So this lesson is more about introducing and being familiar with IJK notation. In the exam, it is usually 3 dimensions, IJK. Okay, again, there's a chapter on Moodle with lots of vector questions in it. So for practice, you should look at those. I can assume you can take personal responsibility for your learning. Yes? All right. So there's a chapter on vectors on Moodle. There's questions in there to practice. The serious students will do this. And the students who bother to show up to this class as well.